were working in a team that someone decided that you need to use Drools for doing something, and Drools is not the right tool for doing that. So I will try to discuss what things you can do with Drools, what kind of things you should avoid doing with Drools, and what the issues are. I'd like to thank this team for organizing and everything that having a Java issue sharing with the projects that are important. So feel free to give me questions. Way better if we use the pointer so you have issues. What I will try to cover is most of the time when I do a presentation, I like to cover a little bit about the Drools history, about the project, about where the project is going. So I can give you a little bit of context, not only about the Drools engine, but about the code platform that we are building as a team. That's why I will start with some history, some basics about the Drools engine itself. So we can get like a clear understanding about what Drools is and how it can be used. I will talk a little bit about the key platform, which is kind of like the work that we are doing right now inside of the team. And then we will take a look at some very basic projects and some examples and some counter examples of things that you will find out when you're on the team. If you have questions. A little bit of marketing here. I joined Webster like 4 years ago, but I've been working in the community for a long time. And I'm mostly related with the JVM side of the project, which is the process engine. But I've been working for those more time than I've been working for JVM. So nowadays I'm trying to finish one of the tool scripts that I will throw out the first paper here. So I'm looking for if you are looking forward to get like a more detailed description about all the things that are covered in the tool. So I'd like to start with telling you a little bit about the history about the project itself. Drools was born officially in 2003 by Mark Proctor and Bob Writer, and they started it because they realized that in the Java arena there was the need for having a rule engine to allow to solve some issues that they encounter in normal Java projects, like taking outside the business logic that you usually put inside your programs and you hide in your code, and trying to extract that so you can modify that quickly and allow to the code in the company to give you that logic quite easily without modifying the entire application. In 2005, Jay was acquired the project, and at that point, Mark and Bob were paid to maintain the project and keep moving forward. And in 2007, they released Drools 3, which was the first version of the project as a framework. So at that point, they got a lot of attention from the community, and they started this community that was growing a lot, and they get a lot of attention there. And they try to share as much as they can about what they were doing at that time. One of the important things that Drools 3 included was the first version of the VTO algorithm, and this was like a huge milestone there because most of the rule engines were designed to work with C, and they were designed to work with tuples, not with objects. So they created the first version of the rule engine, purely designing on top of all the concepts that Java platform uses. You are designed to use with objects, so use your own objects, put your own models inside the rule engine, and the rule engine will take care of all the mismatching between the traditional rule engine and Java object-oriented parameters. Drools 4 in the time was focused on performance and production and to be production ready. That means that a lot of financial companies, a lot of insurance companies, a lot of healthcare companies started to adopt Drools to solve their own problems. At that point, we did like a lot of presentations, we did a lot of Java user meetups, and to share what you can do with Drools and how you can implement it. And it was huge. I mean, there were like a lot of companies implemented it and using it because at that point the algorithm was ready to be used in real life experience. After that, we focused on integrating with some other were related, and some frameworks have shared a lot of things that we thought that rules have like the potential of doing, but it lacks on the expressive side. So basically, in rules you can write rules, in JVM you can write processes, and in complex event processing frameworks you deal with events and how you relate different events together. So we thought that these three frameworks will very fit together and they will complement each other in order to provide a good way for business people to express business logic in different languages for different purposes. So when you see these three frameworks together, we managed to create this new platform that is a key platform for knowledge is everything, and this allows us to have like a big umbrella of all the technologies that allows you to represent business knowledge in any language, and then how to automate that business knowledge into the runtime. Drools 6, now we started in 2014, and it was focused more on the tooling around the frameworks. So until here, we were talking about the rule engine as a framework, the process engine as a framework, and complex event processing. But now here, we are talking about the whole platform with infrastructure, so for deployments, all the tooling around that infrastructure. So we just have things about rules and JVM and CVT as a whole environment where you can model everything, and then you can automate all the studies and test all the studies, and when you can deploy that and consume that from your applications. So what we are doing now is going through that path and moving everything, all these platforms to the cloud. So what Drools is definitely nowadays is depending on what you need. So it could be like a very lightweight run engine that you can embed in your applications. And it's not like a traditional run engine. If you start reading about run engines, you will see that back in the 80s, they were used to have like a rule engine and then just send everything to that rule engine instance and then get all the results back. With Drools, what you can do is you can embed the rule engine inside your application and you can create multiple instances of that rule engine. You will see what the rule engine is. Or you can have a service, so basically you can also have a standalone server that you can do, and then you can create multiple instances inside that server with different set of rules and different things. The rule engine, when we talk about the rule engine, we talk about an inference engine, which is like the brain of the rule engine itself. And when we talk about inference engines, we talk about two different types. That data-driven ones and the rule-driven ones. When we talk about tools, it was more as a data-driven inference engine, but nowadays it supports both. When we talk about the rule-driven engine, we talk more about like some kind of like unlock engine, where we use rules in order to define which is the missing data and what needs to be generated in order to accomplish the goals. When we talk about rules and forward checking algorithms, we talk about what happens when we write our rules and we put some data to the engine, what we can do with the data that we have right now. For us as Java developers, this is a big change of how we think and how we design our solutions, because we go from an imperative paradigm to a declarative paradigm. Okay? And this is kind of like the key thing with rule engines. You need to understand what that means, what it is and when we are writing in Java, right? So you write one line after the other, or the sequence of lines that needs to be executed, and you know for sure that that sequence will be executed. Okay? When you are like in a declarative environment, what you do is you put your rules out there, which will tell you in this situation you should do this, but you will never say, I want to execute this rule at this time. The rule engine will be in charge of the thing, defining when each rule will be executed. Okay? So we will take a look at some of the examples. Quickly, a rule structure, you know how it looks like. The rule is plain text, basically. You can write this in ext5. And it has a couple of sections, the one section and the other section. It is also called left-hand side or conditional side of the rule. And what it allows you to do is to define a situation or to define a set of filters about data. So in this case, we are saying, okay, you have an order with more than 10 items, and with the total of the order that is above that amount, this conditional side will be true, and this will be executed. In this this part, the consequence part of the rule, and you can write Java basically, and you can do whatever needs to be done when this happens. But again, you have this rule, and the rule engine is prepared to have thousands of these rules. Without any problem. And the main idea is that when you have a situation, this will be executed, but you can never imperatively all that. You can never set this rule engine execute this rule. So one of the things that happens, and we will discuss this in more detail. What happens is that people usually confuse this with if and else statements. So when you start learning about rule engines, you will see that a lot of people say that, okay, so you use a rule engine to take all your if else statements outside of your application. If you think about that, it's completely wrong, because if you think about that, then you will want to use the rule engine as the basis for your else statements, and then you will want to call those else statements. That will never happen in the machine. You need to avoid thinking that way. To get a little bit of background about how the rule engine is composed, you will write your rules in the PHP files. You will write all the rules that you want to describe your business logic. And then what it happens is that you will compile that using an algorithm to create the pattern matching network, which basically is a way to optimize the comparisons that need to be done. Okay, so most of the time, again, going with this if-else statement thing is that if you have 200 if-else statements and you have a set of data, then you need to run over all the if-else statements. In this case, this algorithm takes care of that. So if you need to check like person and with an order with an amount, the algorithm will take care of not comparing with all the other options. So you have the rules compiled using this algorithm, and what you have on top of that, you have a working memory where you're going to store all your data that you want to record. Yes. What happens is that by using those rules, what you can do is you can get some inferences, which means that you can generate new data on top of the data that you already provided. Right? So we will see an example of that. And that data can be inserted again into the working memory, and you can evaluate on top of that the data that was generated. Another really important thing, in the same terms, it's important as this sentence, so from imperative to declarative, you definitely need to understand to use this graph. And what I'm trying to do here is I'm just trying to show you like the main key things, so it might not make any sense at this point, but when you use rules, you need to come back to these graphs, because these graphs are the ones that basically guide you over the implementation. So this graph here shows the loop, the execution cycle of the rules. So you have a lot of rules, you have data inside the rule engine, and what the rule engine does when you put your data inside is it goes and matches all the data with your rules. And what happens is that when you put data inside the rule engine, it puts off that a lot of rules gets activated. So you can say, okay, all the inputs here have this rule. Let's imagine that we only have this rule, and you start adding new orders into the rule engine. Okay? What it will happen is that some of those orders will cause this conditional expression to be true, which means that this might need to be triggered or executed. Okay? What happens is that you start adding orders, some rules might get activated, but this cycle can only execute one rule at a time. It cannot execute more than one rule at a time. So you can have a lot of rules active to be executed, but this conflict resolution strategy there is in charge of saying, okay, I will pick just one rule. And how it will pick that one rule is up to the implementation of that conflict resolution strategy. Okay? It might be based on priority, it might be based on something else that we can define. But for now, we can take that as a very example. Which will be. It will pick one, we'll execute that one, and it will do the cycle again. Okay? So it will not execute, it will have 100 activations, it will not execute 100 activations. It will execute one, because what can happen here is that when you execute that rule, when you execute that need to change data, and all the other orders are not longer matched by that. They are not longer changed. So we need to cancel all these activations and calculate new activations. The algorithm decided to do that cycle in the most efficient way possible. So you don't need to do handle evaluation step, and that will happen. Going forward, again, as I mentioned before, tools is not longer alone. It's also in conjunction with CEP, which is complex event processing, which add an extra dimension to our rules. So with complex event processing, what we can do is we can evaluate temporal events. Okay, so now instead of having orders, we can have real-time events from a sensor, right? So we have a raspberry Pi with the distance sensor, we can start having the distance sensor events, and we can aggregate and correlate and filter those events. So we can have something like distance event, the value greater than a meter, then we will execute something. And we can have the rule engine evaluating those in real time and reacting in real time to our. JVPM is a process engine. How many of you know what the process engine is? Automated business process, which basically is another way to represent business knowledge. So instead of writing rules, which are like this application, you have a more procedural form where you draw a model and will be executed by the Octaplanar is about optimization problems, so you can write optimization problems with hard and soft constraints. That's a different topic for another topic. Interesting. We have the server, which is basically an web application with some endpoints, for service endpoints, to cause rules, process, and event endpoints. And then we have all the tooling on top of this framework that is called Verify, which basically gives you this workbench environment where you can have like a web ID, where you can design your rules, design your processes, and then create runtimes for those processes. Yes. Yeah. So there are like several scenarios to do that. So basically, one of the things that you wouldn't want to do is to apply that in runtime directly on top of your own rules, because instead of doing that, you can like have both versions at the same time. So new request will go to the new, the old ones will stay with your rules. Yes. You can do that out of runtime if you want. Yeah. Most of the time, what is suggested is to have both versions or like different runtimes, different versions. So not great, because it depends on the changes. Sometimes you can do that, sometimes you can. If you start like changing objects or the attributes inside the objects, it's more like a Java limitation than a Boolean limitation. It really depends on what. So let's go quickly on top of look at the APIs of the rule engine itself. What you can do with the rule engine itself. So basically you have a key container, which is where you're going to put on the compiling rules. The key base is the specific compilation for all the rules or the processes. And then the key session here represents the working memory that I was showing before, which is basically the space in memory where you just put your objects to generalize by the rule engine. So you have key methods here that allows you to put information inside the rule engine, take information out of the rule engine, or update information that is inside the rule engine. This is kind of like common. I can think about some other frameworks that have something similar to it, but in the Java world, this kind of really So in order to work with the rule engine, you need to give the rule engine information. You do not take information from it. That information. And then finally you have this method that is called viral rules, which basically will execute all the right-hand side, all the consequences of all the rules that are true. Key scanner is for doing what you were asking, so basically to monitor a set of rules, and if they change, you will load that, and they start displaying grade all the work. And we'll take a look at this. So quickly, just most simple truth project that you can create. It's in the human repository. But I thought that it would be a good idea to show you the things in here. So in order to add the rule engine inside your application, you need to define just one label dependency or one, which is rules compile. By consequently, you have rules core and API, which are required. You need to have those. The API is just all the interfaces that we are using to encapsulate the rule engine, the process engine, or the engine. Tool 6 provided also integration with CDI. How many of you guys know about CDI? Which is I think that is quite useful because it uses all the configuration side of it. Traditionally, rule engines were like bootstrap and computers or things like that. Java lines, code lines to configure the engine and to get an income from the engine. I'm running with CDI. So if you want to run with CDI, you can, which means that you can inject the engine instances inside your application by listing. And we follow some of the CDI nice things about like conventions or configurations. So we provide this table in the XML file, which basically define the rule package. In previous version of rules, we have our own proprietary form of file package instead of rules, so you can just distribute this binary thing where you have your rules already optimized for runtime. But now we just went back to that and just follow the Java community and use the Java file to manage our rules, and we just put this file inside of our projects, and that jar file is recognized by the rule engine as a rule package. You can see that our rules are written inside these URL files, which are text files, and then let's take a look at the most simple so this uses CI and this uses well as a CI container. So this is bootstrapping the container and what you can do now is to do this now. So you can inject in the session and then you have the instance of the rule engine ready to use. Okay. Let's take a look at the rule that is being loaded. So you can write this as it. So you can have an object. I will do something, in this case it's going to be more than just giving the object itself, but something whatever you want. So I'm inserting an object here, this is me, and that's basically creating an instance of the engine, inserting the object. This object will cause that rule to be activated, and when we call the file rules, that will be basically the customer side. So feel free to take a look at that and get them. I want to go over what kind of things you can do with the rule engine, and by that I mean what you normally do. It's kind of important to understand that rules is non-intrusive in the sense of that you can put any model inside it. So if you have any Java model that you're using, you can put it in there. You can also, any other library model that you want to use, in there. Most of the time, what is recommended is try to write rules that are not extremely technical. Try to write rules about business logic and not technical to solve technical problems. That's one of the recommendations. So avoid putting an hibernate session inside the because of course destination. But you can do it. So what you can do? You can print the data. Quickly, let's take a look at most of the examples that I will be showing here are quite basic, but at the same time, I want to make sure that I can show you an example that you can extrapolate to your own information. And for every input file that I will be showing here, you have a text that demonstrates. So here I have a model, I have person, I have a rule that different persons. Okay? This means for person that I have, I will execute this. I'm using this to add that to a variable, so I can then reference that variable in the mechanism. Then I can start adding filters inside the person. So this is called object type filter. And again, it will filter every person that we have inside of our rule. So if we put two persons, this one will be activated twice. And it will be fired, what we call viral rules, and it will be fired inside that viral rule cycle using the cycle that I showed you before. It will fire one ring, and then it will reevaluate if this one changed something, and it will fire the next activation. Okay? Does that make sense to you there? Yes. Let's move on and then again, you can have more than one filter in the same group. Right, so we are filtering age and city. And all these filters are kind of optimized inside the algorithm. So when we take this TXT file and we generate this binary in representation of all the rules, that algorithm takes care of doing all this comparison in the most efficient way possible, which means that if you have 10,000 of these kind of rules, it will be very optimized. So we use a couple of hashing mechanisms to make sure that, so if you have like 3 or 4 or 10 different ages range ages here, so like from 18 to 25, 25 to 34, we know that there will be a hash associated to that, and we can do that to identify it. And the other thing that we can do with rules is to filter taking advantage of difference. So basically, a student is a person, it's not a person. So if we put a student inside of our rule engine, it will trigger all the students' rules that are triggering the student, but because it's also a person, it will also trigger the person. Okay, so it will be the student, it will be activated, but all the person rules will be activated. You need to know that will happen. Yeah. Yes. Yes. Exactly. Good. Yes, yes. I mean, if you have like a syntax error here, if try to compile these rules, it will fail and it will tell you this line. Go there and fix it. Yeah. So you have two things. You have an text editor and also an IntelliJ plugin that gives you some syntax highlighting and it gives you it tells you errors while you're running. As I mentioned before, we are building on web platform that is supposed to provide you some more business-oriented editor. So you don't need to type these very like technical things like object types. Right? Exactly. So this is the technical thing. Right? So this is what the Java developer will run. Going to the other extreme, like being friendly with business people, is really hard. It depends on tons of other things that are completely outside of the Java scope. We are moving towards that direction, but we are not there yet. So the idea is that the new platform will provide you like from the most technical thing to write tools, this kind of format, to use DSLs, which are domain-specific languages, where you can add some of these phrases. So you can say something like, there is a student. You get that on you show that. Show that. It executes. So it executes this part one at a time. But one other important thing, again, we are in this declarative environment, which means that the order of the rules doesn't matter. It doesn't matter. So if you put this rule, so the first rule that is in this file, it will not fire first because it's in that position. You can just move that rule down, and it will be the same for the rule. Okay? So by ordering the rules, you're not doing anything. It's not that the rule is really ordered first this one, then this one. Not happening that way. So basically, there is another section that you shouldn't. when you go in that direction, you're going in the right direction. So there is this place here where you can put rule attributes, where you can put priorities. You can also put rules in different groups. So one group will be related first, and the other, so there will be some kind of priority per group. There are some other attributes there that allow you to do it nicely. For the rule engine perspective, it doesn't really matter if we try to execute everything as possible. That should be priority. Yeah. So if you have a rule attribute that is priority, you do the higher priority. But it will not. Yeah. So it will fire that rule first. Yeah. It's more like logical priority. So basically, that's one question. So basically, as soon as you start writing rules, as soon as you have like 20 rules, you should realize that you need to start testing. Because because you are like writing logic, which is and you need to make sure that that logic does what it's supposed to do. So writing testing is quite important. And even writing like more basic testing. For I'm using here this one. So basically I'm using here a given again to see the test. This is basically I say one, I make sure that I fire one rule. One of the most basic things that you can do, but it's really important to know that if you add more rules, you know that when you were testing one rule, another rule goes activated on file and something like that. Sure. So, yeah. Okay, so until now, what we have been seeing is only server side, right? So we have the rule engine in the server side. Okay? And what you can do is you can expose the rule engine, or you can expose the service that is hiding the rule engine. So you have to rewrite calling that service. Right? And you have an instance of the rule engine with data. And what you can do is you can use a set of mechanisms that we can see to interact with the outside world. Okay? So you can put inside the rule engine, okay, message or a service, yes. Yeah. Sorry. Yeah, you can do that by using global services. You will get it. So here basically I have a server that's inserting person. So I just want to make sure that if I insert the person, I just get one rule activated. Okay. If I insert the person with some specific data, I will get something there. But again, the important one, and I believe that this is kind of like very good because it opens the possibility to go like using the data. So you get all the rules activated, all the rules that come from the person. We also use it for you can do more complex things. Now notice that I'm showing only like the visual side because that's what we call the DRL language or the useful language, which is the conditional side, is the important part, very good job. One quick recommendation is because here you come in Java, it's tempting to go there and put a lot of history or logic inside there. No. What you do here is you do some logic difficulties or call services that's what is supposed to be done. So, for example, is that if there is fire, set up the alarm or on the speakers, it should be something like that. We have an order with these characteristics, then we need to trigger the approval. Don't have a lot of logic there. You can tempted to go there and put so many statements. Don't do that. Please. Yes. So that's why I was saying that testing is really important. You can never, well, at least not now. I mean, it's kind of like the end goal of the rule engine to allow these people to change things on runtime and apply that directly. That never happens in that. You need to change it. You need to make sure that you run all the tests. You need to make sure that there's enough consistency to run that in your environment and then just move on. What we are providing with your platform is the whole cycle. So you can do the change. You can see if it's working or not, you can simulate that, and then you can just move that to production. Okay? That's why we think that all the tooling on the platform is kind of important. With the framework alone, you have the HTTP file, you change that already to the server. Or terms that are really important in this structure. Yeah. So the concept itself doesn't exist like that, but it exists like an engineering term. So basically what we have is rules packages. So we can create different rules packages for different usually per department, per user. So one of the things that you can do with this k-module external file is to divide all the rules into different groups. So then you can test them separately. And because rules is functional, you can create one rule engine instance per of these rules. So you don't need to think about having one rule engine instance for all your rules. Because when you have one rule engine instance for all the discount rules, for all the invoicing rules, and for all everything, then it gets messy and it gets fluid about everything that's going to work on. So one of the things that really like push a lot on having this separation. So we can create like rule to rule instances without thinking about that process. Firewall rules to roll out yes. Yeah. So you will end up having one key session, which is the rule instance, per rules that you create. You can even have multiple rule instances with the same rules. You want to load one. If you don't want to put all the orders in the same instance, you have 10 of them. Exactly. So part of implementing, creating a good implementation of all this is designing that, knowing when to split the process and how to divide that, and how to move information from one rule engine instance to another. Sometimes what you need is start doing some validations of the data, and then you have to do the discount. And for that is why JVM and Drools so well together, because in one you can define the process of what are the things that you need to do, and how you are going to move the information from one task to another one, and those tasks can be really unique. So that's why it's kind of like Yeah. So you can feed the data, you can turn the data. So it's really complex. So let's say you can have rooms and persons or rooms and houses. You want to do multiple patterns here. And this is where you can find more complicated conditions where, for example, here we are evaluating that we have a house and the house contains that. So we have this variable here and we use that variable to see that the room that we are evaluating is inside a house. By doing this, you can add as many conditions as you want here. And the important thing is that when you put information inside the rule engine, for example, to the house, as soon as you put information, it will know that there is already part of this condition inside this room. And as soon as you put the room there that matches this condition, it will go. Okay? So it's kind of like waiting until having all the data in order to activate this rule. So, and that's like, kind of like going again with the if-else statement. It's like when you write an if, you execute it, then if you didn't have data, that's false. But if, on the other hand, you have that, as soon as new data becomes available, it will be executed. Yes, the only limitation is like not very logical. How complex is the word function? The other thing that we will do later is about the amount of filters and the type of filters that you can write here. You obviously have like a logical relationship, so if you want to evaluate the variable here, and yeah, and if you have multiple rules evaluating the same kind of like conditions, so if you have a lot of rules and houses, it's for a performance reason and based on the algorithm, it's better if you have them in the same order. To share them. So you have a house that it has a list of rooms inside. Okay? Then you have rooms. Okay? Let's go through. I will go back to these examples to show exactly what's happening in here, to give you some advices about what not to do. But yeah, this is expecting a room and a house. The house itself has a list of rooms. So that's why you have base, that contains the base names. So you can do also creations and annulations of data, which is where it gets more because you can do something like let's say you start putting persons inside of the engine, and then what you can do is you can calculate all the average ages for all the persons that you have in the workflow. So this case is true. It's basically being true all the time because if you have at least one person, the average will be average. Right? But you can start adding computers there, which is again very difficult. So that means that if the population of persons that we have inside of our related is over 50 years old, over that age, we will treat that. And you can combine these variations with some other conditions, right? So in this case, we have a room, and the room gets has a capacity. So again, we are going over all the persons that are inside the room, and we can basically say, okay, the amount of persons that we have inside the is greater than the room capacity, which basically means that. Again, it's a simple example. You can see that all the rooms are not being matched. And that's where we can jump to the point, which is the inference. So we can use the inference chain to do more than what we should do with an inference statement. With an inference statement, we can just evaluate the data and based on something else, but in this case, we did not change, but we can create data based on data that we already have. And this is where again we go back to that loop execution. So we can now go to very simple example to show a couple of things here. So we are here already about person, university, and then the row here says this the list inside the university of all the persons already enrolled at the university. So this will be saying, okay, if you have a university, if you have a person who's enrolled at a university, then that means that we have a new student. So that person is a student. So what we are doing here is we are creating a new object. And we are inserting that information inside of the running. So we are generating new information and making that information available to this person. So we have rules about students that can be now evaluated. We generated the information and then we can execute, we can start looking at this rule. So this rule will be evaluated based on this new information. And here what I'm doing is if we have a student, then the student has to student class, which is in the layer there. So we don't have that student class as an object in Java, but what we can do inside the Java language is create this kind of types, logic types, which are objects. So we don't need that class definition, but we will create that for us. And the main idea is to not require to have a Java class for something that is really only used Again, now if we insert this information inside the rule engine, then we can start writing rules about the platform. Yeah. Yes. 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 Yeah, I'm sure. Yeah. It will be evaluated. Yes. True. Yeah. It could be the only thing that I would assume is that it will not entity, it will not evaluate the school again, because this new student is not enrolled in the university. We have two options here, so that is wrong. But we have two instances, so we insert a new person object, and one person instance. But we have one instance of person. We insert that. Then we create a new student. And at some point we need to have enrolled that person in that university in order for this to function. But this new student was never enrolled in that university. So the instance is only the instance, it's never in that group. So it will never function. Regarding loops, we will take an example of that. In this case, it's not looping just because we have different object instances. That makes sense. But the example is wrong in that sense. Right? So I shouldn't be creating something that is an extension of the other. But if we remove this, and if we do, so if we remove the university check, if we do this, we do it for
So we are usually handling user things over the memory to the user usually not first and in both so we can measure so
it will not because
I'm not sure what
so the difference is that when you insert this person, right? So you created a new instance of person. And that instance has a hash. Because per instance, okay? And when you create this new student, it will be different. So you now have two instances, but the second instance is not functional. All those kind of questions are kind of like really, really important because when you start writing rules, you will start facing all those issues. It's like not looking or waiting, it's matching or writing. Java developer, you definitely need to go a little bit deeper. You can try to learn a little bit about the algorithm that is really yeah. Even if you go outside, it's obviously what you can see here, and another question that you might ask, when you see the same stuff, so that we create a type, so the rules is up to you. But what happens if you want to know how many student backpasses are? Say, what do you want outside? If you're outside, you don't have that type. You can get the information. So at the end of the day, you can get that type. But again, most of the time when you create this kind of stuff, it's just a logical thing. You're trying to use it like not just be a fast type.
As in, for example, let's say we have two rules, so one is ours, then there's no like say words from the other one.
It can be done by adding some of the attributes inside. So inside the top of the one part, you can add some, you can put like rules. So now this rule is active, so we just evaluate that. But again, that's kind of like a tricky thing because the rule is not the same to itself. It will not be fired if it's true. And it will be evaluated. That's the algorithm itself, it will evaluate all the rules that you have in the rules. Not in the rules type, but in the rules type. All the rules that are loaded in there.
For me, I never really did the code to understand how I can make sure that I basically don't create even not necessarily one rule called or one rule called B and also B A.
So there is one attribute that prevents so it prevents that from the whole group. If one is changing something that another group has already, you can avoid experiment. That property is called automatic. If you're trying to solve that you don't have any example of that. But what I'm doing here is that if I have persons in London, I will want to track those persons. So, so as soon as I insert the person here, and the person matches that city, what I will do is I will create a new tracker again, there, and I pass the person. What happens? As soon as I change the person location, that tracker will be retracted because it will not block the truth. Because I'm doing this insert multiple here, the relative will take care of removing that tracker from that person. Okay? So I am creating information based on the information that I have, but that information will be available as long as the condition for what it was created was true. And with that, we will have a lot of very, very interesting things. This is a very simple example, but if you start thinking about what the rule is, insert multiple, it will make sure that it is there. So that's kind of like really important because it will keep track of the truth about the information that you generate. So the tracker detects this condition. That condition is no longer true. I will report the facts and information that was generated based on when you, yeah, of course, if you change the as soon as you change the person, the evaluation will happen. When it will be removed? Yeah. Yeah, sure. The rules are never like all evaluated. So basically, something like that. It will trigger. So basically, remember, you are not going to remove the tracker. The engine will remove the tracker for you as soon as you change the first location. Okay? Let's say you have a again, with my calculation now, when we take a look at example, it's really fast. So, for example, what I'm doing here, I'm creating a person, I'm inserting what person in the working memory, and I'm calling file rules. At that point, I will have a new tracker inside the working memory, and I can say that if I want. The next thing that I do is I go to that person, I will change the location, and I will update. And if I file rules, and I check how many trackers do I have in my working memory, I will not have any tracker there because it was removed by the engine because the first location was changed. So the condition was no longer true. The information that I created before is no longer available. If you run this step, you can see out how the resources are very handy to know what's going on. But basically what it's going on is maybe it's saying here, okay, I'm inserting an object into the person. Next thing that it says is that I've updated that. So if I insert an object, I'm inserting the tracker now because I'm evaluating that rules in true. And next thing that happens, I go there and update the object. And then what happens is that I will remove this is the end telling me I remove the tracker because the condition was no longer true, so I can do mine. So that's kind of interesting. You can build like a lot of examples of that. If you think about the IoT or the Internet of Things and keeping track of state. Yes. It's not like very typical. But in that case, it allows you to separate the data insertion to the reaction.
So we need to get firewall.
Yes.
You wouldn't have fire.
Decide. So basically, if we go with the one tool at a time, there are no more resources. So what we can do here is something that I'm not sure what we have here is a session, it's a working memory that is stable. So what you can do is you can insert all the data that you have, for example, insert a person, insert a house, a room, student, or whatever, and then at the end, modify rules. Or some other thing that you can do is you can use another method that is fine, which is called fire control, which basically allows you to be in a reactive. So as you insert data, it will fire all the rules that data is activated. You usually use this kind of way in tests where you want to insert data and then know how many rules are activated. Okay, so in the interesting, it's very important to understand that we can create all the data that we have, so we can start trying to point to the data, which means that we can just take all the information we have there, take all that information, which is the rule of the rule, and that's how it comes. You can explain that query again. You can explain that query by saying this is more imperative. You can say, well, give me all the data now. All these queries are done. You get all the person from here. What do we have? Matching that expression. You get all the person from here. Or you can use line queries. Again, you can do some kind of like facial dictation as soon as that query is matching to the true. You get the data matching that query, you notify it into your application. So for doing something like information, right? Like you have a session and then you have a client and then you need to be notified in the live query. So you can send push notifications to the browser or you have a rule session there, you're putting data on the UI, and as soon as something is recognized, matching that query, you can be notified to the client side. That's not a rule, that's a query. But so we have a couple of examples showing live query and all-in-one query. So what I'm doing here is I'm generating person objects. I'm inserting all the person objects, and firing all the data, and then getting all the that way, and then sending one of the transfers. Only first after each we do the number. If you want to go for the library, over the library, set that in the mail process, and then you need the one. So every time that the new open row for that place, it's already there. Notice that it's kind of important. So again, it's kind of like, you know, when new data is available, but you also can notify when data that was available is deleted. So you can use this also in conjunction with the self-logical. So every time that a new tracker is deleted because person location changed, it can be also modified. For that data. And then you got audit. For all the operations that we're going to execute, you can get this very detailed note about what's happening and why. So it basically gives you that the tracker was removed because the condition was changed. And you get all the inference change there. So that's kind of really important when you have tons of tests. So if you have that you have a new person with different university, and that's a student, then you have a bus pass, and then you have a bus pass, you have a library card or something like that. You get all the stack about what was happening and why the engine was creating information. Good. Okay, so this is not removing things, it's logically. Yeah, so basically, you need to think about like the work memory or the LND instance as like your world. So you have people there, you have housekeeping. So as soon as the information is changing, the rules that you have described have to match to that information, you will start getting new information. That information is in there. It's not that it's going to be changing in your database range. So it's going to be changing inside that offline world. Then what you do with that information is up to you. You want to take the tracker or the student or whatever information that you have in there and store it in your database, and just go to service and do it. So this is kind of like separate space to do this kind of evaluations that you can keep live there to make sure that all the business schools are being all the standards that are being met for the insurance company that they will sell work in that environment. So basically the examples that I just showed about like having a student and the background, that's forward chaining because you start putting data in the house and you change forward the next step based on the information that you create from the video. So that's changing the much from the or advanced support. That's forward chaining.
So, in common features of arbitration,
You can do share across both rules, and then in all the other rules you are going to have an extra condition. You can just be faithful to extend that rule. Okay? Okay, so again, so I just mentioned the rule of which is kind of like questions that we have already answered. So if you are going to start with using rules, you should start as simple as possible instead of trying to do everything with rules. One of the common symptoms of starting using the engine is that as soon as you start understanding how it works, you want to start always authority. Start as simple as possible. As I mentioned, because rules allows you to put that inside your applications, you are also tempted to go and start gaining a lot of instances there inside your application, which might be good or bad idea depending on how your application looks like. So you need to evaluate how many rules entities that you're going to be using, and the number is like a lot, and you might start growing that instance. Again, comparing with these class statements is not the best idea ever, so just try to avoid doing that. Try to avoid thinking about like I have this class statement, then I can just use to relative work. Again, as I mentioned before, too much logic on the right hand side, that's a good sign that you're going in the wrong direction, so try to avoid that. Try to keep the rules as logical as possible. Try to make sure that the model that you're using in your rules are like very business oriented. Once you have a lot of technical stuff here, it's fun. If we look, it's one of the things that we really recommend because time as soon as you start using it, what I have here is something similar to the example we were looking for. We have a person that is checking for the age, but what we do with the right hand side of the rule is we change the symbol. That means that the first was changed. That means that that will be divided again because that only was changed. So we need to make sure that we are checking. And because the age wasn't changed, we will have to so the application will go into it. For avoiding brushing, the stack overflow section will be we have the assignment in the file method, which says if we have we are going to only fire the first 15. Okay, so we can avoid looking extremely by using type and stuff. So we have this kind of information where we can use but again, the most important lesson is that we definitely need to have tests, so we know that if you are in the rule that is looking, we will start.
You're like a workaround.
Sorry? It's a workaround. Yeah, it's a workaround because you never know. You don't know what's going on. There are some other ways of handling that, which basically are good practices about how to write the condition. So basically, of course, you need to be as detailed as possible in writing the condition. You need to be as restrictive as possible because the more restrictive the condition is, the more. Yeah. No, it's not the chance. It's more about like the correctness. Checking exactly what you need to check. You're not like leaving the generic condition there that is matching the other part. True. Yes. So okay, in order to answer that question, that's the point where you definitely need to go a little deeper in understanding how the algorithm works. When you understand how the algorithm works, you will realize that the conditional part and this part is detached. One is Java and the other one is an algorithm which creates like a tree structure for doing the evaluations in the network. So in that tree, the only thing that it has like a bit at the end saying that when all that the conditions are true, you are going to execute this answer. So it's kind of it's not that easy to evaluate what would be the consequence of doing that. Good. using this dimension 4 to interact with the outside world, using globals, which basically allows us to say, okay, we have the service, which is external to the rules, to the blending, and we want to call this inside the in this case, I have two things, so I have my service and my data providers. One is for internally, and the other one is for getting information outside. So in this case, let's take a look at the first tool. So we have the tool, every time that we put the first tool here, and we call the file rules, we will be calling this up. This global is my service. It's an interface, which means that we can run this rule against different implementation. We have different instances, different implementation. And then see the implementation of that service that is being called. It's clear that if you put here something that's going to be database with a lot of stuff, every time that you execute this rule, it's very long. So if you want to have like very important operations here, you need to ensure that this is called as a single. You just put the message somewhere. If that changes data, then you will need to have like this one to make sure that that data is changed inside the so, something that we go here. So what I'm doing here is I'm creating something service. We take a little time to call. We create like 20 verses, so we call that. We call that 20 times, which means as soon as we go to the file rules, if we go over all the 20 verses, then we call that service 20 times. These file rules will not turn the thread here in the finished calling over. So by implementing an asynchronous thing, it will be on your applications. So the one that is calling this, you will need to keep the session up, running that, and return to the service link. For example, let's say that you want to create the REST. The REST endpoint will need to serve, so basically, now this case we just do all the stuff in a different way. So it's more up to your application on when you execute that and how do you do that. Because you know that as soon as this file rules is finished, then you can export your release. But yeah, it's not like yes. So instead of putting the try catch in the room, you should put that inside the service. Yeah, so yeah, exactly. So you should avoid trying to put that kind of stuff. Instead of putting it in there, just put it inside. Or inside another layer, so basically you can always absolutely service in that very handy way. Again, this is all working in memory, so wording all transactions and all that stuff, it's not affecting the data key. So basically, in order to work with persons here, you need to go to the database outside in your application, get all the persons, and put all the persons that are going. So there are several points. So basically, so basically, what they have is that you have a layer for catching in the error. That layer will be in charge of inserting data into the data. And then you do the installation. And that's kind of like, again, it's going back to how you can use this with the processing. It allows you to deal with all those situations. Processing are much better in handling errors and in compensation. So when you call a service, what you want to do is that if the service fails, you want to make sure that the state is consistent with your environment. So you do the debit with your bank account, you want to make sure that the balance is correct. So if you do that, if you call an external service and the service fails, or it's success, you probably end up. So you have to say that being there, and also doing response. When the service changes something that's important there, you need to update. So it's kind of a couple. It's not like the responsibility of the community, it's how to use this. It's fine on the web, but at the same time, it's kind of like the logical thing to make sure that what we write here, it does. If you want to delegate that decision to the one that is performing that service call, you need to make sure that that team is in charge of updating. Sorry? Again, so if you call a service here, you need to remove them, so whatever that you can have, you need to do the same. So if there's 50, you never know if it's over. Alright? Unless, yeah, that's it. It depends here. If you take a look here, this rule is not changing anything. So this rule will not be removed. And you shouldn't change data if you don't know the answer. Right? So you delegate it to call the service, and then you make sure that somebody from outside will update that information. Okay, so as soon as you call the service, then you break the exception. And if the answer comes back, and that the information is given. That's kind of like the normal standard. Yes. Yeah. So basically, you shouldn't put anybody. That should be outside. Here it should be ongoing. Okay, so what happens? So basically, what it does describe situations. What we do logically in those situations. The thing is just involves something external about what happens. The advantage of rules is that you can decouple concepts in rules that are not supposed to be hidden in your technical application. Like, for example, what's an student? The concept of what's an student is like a logical concept. It comes from the reality. So how do we define a student? Right? Today, a student is a person that is in university and is older than 18 years old. But tomorrow, the world will change something, and the student is something older than 21 years old, and that's not an easy university. So then you can just go and change the rules without changing any of the information. That kind of like mindset is the one that leads you to try to use blending instead of saying, hey, I just want to try. It's kind of a completely different picture. Also, what usually it's a good combination of blending is when there is no, when you have a set of things that you need to do and there is no well-defined algorithm to solve all of them. Right? So you need to solve the problem, but you don't know how. But you know solve rules. So you can start creating rules to solve and identify situations and then execute some logical operations. And based on that, you can have a program application looking at what the rule engine is using or creating information. Then you can do some services for information. Yes. It's not expanding, it's improving. I can show you. So basically, I have this project with a lot of examples. And I have this table in XML file. So basically, if you define a table in XML file, you define the structure of your packages and processes. If you don't put anything, all the rules will be loaded in all the related instances that you create inside the package. If I just build one rule engine and I don't define anything here, it will just take all the rules, put that all the rules inside the same engine, and as soon as I put a person, you can have 10,000 rules saying different things about person or the UV market. What I can do is like I can split that, which is two tables, which are basically different